This video is going to be about the connection between combinations and Pascal's triangle. So if we remember, Pascal's triangle is a triangle that's made up with, you start with 1 at the top and each subsequent row is made by the entry above it. So there's, for the second row down, you've got 1 above, and then in the second position you've got 1 above. Now in the next row down you have 1 above, in the second position you have 2 above, 1 above, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so that's Pascal's triangle and continues on infinitely. There's heaps and heaps and heaps of patterns with Pascal's triangle. So many cool things happen with Pascal's triangle. But the thing we're going to have a look at with this in this video is just one really cool thing that happens. And it's the connection between when we have a look at combinations, as in 4 choose 2 or 10 choose 5, how the connection between the Pascal's triangle patterns. So if we just have a look, let's have a look at 2 choose 1, 2 choose 2, 3 choose 1, 3 choose 2, 3 choose 3, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Okay, so if you pop that into your calculator, you probably should do this as you're following along. Okay, so 2 choose 1. How many ways can you choose 1 from 2? There's 2 different possibilities. 2 choose 2. How many ways can you choose 2 from 2? There's 1 possibility. How many ways can you choose 1 from 3? 3 possibilities. How many ways can you choose 2 from 3? 3 possibilities. 3 from 3, 1. 1 from 4 is 4. 2 from 4 is 6. 3 from 4 is 4. And 4 from 4 is 1. So, can you spot the pattern? 2, 1, 3. Now, of course, I haven't written everything down. I've missed out a few of the entries, but hopefully you can start to see a little bit of a pattern. 2, 1, 2, 1, 3, 3, 1, 4, 6, 4, 1. And if we continue down, you'd also get the 5, 10, 10, 5, 1 pattern happening. So, by doing that, just doing those few little things, we can start to see there's a pattern between the values for the combinations, how many possible combinations we have in different situations, and the values of Pascal's triangle. So if we have a look at this 3, okay, this 3 and this 3 here match up. Okay, now if we have a look at this one here, if we look at, this is row number 0, row number 1, row number 2, row number 3. Then, if we have a look at our position, these are all the position number 1. No, sorry, position 0. Position number 1. Position number 2. Position number 3. Etc. And down we go. So when we have a look at this 3 here, this is row 3, position 1. Row 3, position 1. Let's have a look at a different value. Let's have a look at this 6 here. This 6 and this 6 match up. This 6 is in row 4, position 2. Row 4, position 2. So that means you can get a general bit of a rule that when you have n choose r, if we look at that on Pascal's triangle, we can do a shortcut by saying you go for the row, make sure that you row in the top, and then the position in the bottom. So therefore, if we had 100, choose 17, we would look for the position that's row 100, position 17. In the same way that if we knew a position on Pascal's triangle, if I were to say what's in the 89th row, in the 52nd position, what's the value in that particular spot? And you could say, well, that's the same as saying 89, choose 52. You could pop that into your calculator. That's going to be a pretty massive number. I'll leave you to pop that into your calculator and see if your calculator will even give you a value, because that's going to be huge. But I hope that gives you a little bit of insight into what Pascal's triangle is all about. There's heaps and heaps and heaps of patterns in Pascal's triangle, but this with the combinations is just one, and it can be a really helpful way of remembering doing your combinations really quickly. Plus, it also helps with some of the larger patterns. So, hope that helped. Let me know if there's anything else you would like to know about this, and we'll talk soon.